Sawing wood. Factors affecting lumber quality during sawing. The quality of finished lumber is not just a matter of the raw material. It is a complex interplay of various factors that begin the moment a log is positioned for its first cut. Understanding these elements is crucial for anyone involved in the timber industry, from sawmill operators to woodworkers, as they directly impact the structural integrity, appearance, and value of the final product. Achieving high-quality lumber consistently requires a deep knowledge of the sawing process and a commitment to controlling the variables that can compromise the outcome. The journey from a raw log to a usable board is fraught with potential pitfalls, and navigating them successfully is the hallmark of skilled lumber production. Each step, from the initial assessment of the log to the final pass of the blade, contributes to the overall quality. Making a comprehensive understanding of these factors is essential for maximizing yield and minimizing waste. One of the most significant factors influencing lumber quality is the condition and type of the sawing equipment itself. The sharpness, tension, and alignment of the saw blade are paramount. A dull blade, for instance, will not cut cleanly. It will tear wood fibers rather than shearing them, resulting in a fuzzy or rough surface that requires extensive secondary processing, such as planing or sanding, to become smooth. This not only adds time and cost to the production process, but can also reduce the final dimensions of the lumber. Similarly, improper blade tension can cause the saw to wander during a cut, leading to boards with inconsistent thickness, a defect known as washboarding or snaking. The set of the saw teeth, the degree to which they are bent outward from the blade's body, also plays a critical role. Too much set creates a wide kerf, wasting valuable wood, while too little set can cause the blade to bind in the cut, generating excessive heat and potentially warping both the blade and the lumber. Therefore, regular maintenance, precise calibration, and the selection of the appropriate blade type for the wood species being cut are foundational to producing high-quality lumber. The characteristics of the log being processed are equally important. Wood is a natural, non-homogeneous material, and its internal properties can present significant challenges during sawing. The presence of internal stresses, which can be inherent to the tree's growth pattern or induced during felling and handling, can cause the wood to warp, cup, or twist as soon as it is cut and the tension is released. Knots, which are the remnants of branches, create localized areas of dense, cross-grained wood that can be difficult to cut cleanly and can dull blades quickly. The grain direction itself is another critical consideration. Sawing a log in a way that is not aligned with its grain of practice, known as sawing against the grain, can lead to tear-out and a rough finish. Furthermore, the moisture content of the log affects how it behaves during sawing. Green or unseasoned, wood is softer and easier to cut, but it is also more prone to significant shrinkage and warping as it dries. Conversely, drier wood is more stable, but can be harder on the equipment. A skilled sawyer must be able to read each log, anticipating its internal characteristics and adjusting the sawing pattern accordingly to maximize the yield of high quality, stable boards. Finally, the human element, the skill and experience of the sawmill operator, cannot be overstated. The operator's decisions have a direct and immediate impact on the quality of every board produced. This begins with the initial positioning of the log on the carriage. The operator must decide on the best opening face, a decision that will determine the grade and dimensions of the lumber yielded from that log. An experienced sawyer can visualize the potential boards within the log, working around defects and maximizing the amount of clear, straight-grained wood. The feed rate, or the speed at which the log is pushed through the saw, is another critical variable under the operator's control. Pushing the wood through too quickly can overload the blade, causing it to deflect and produce an inaccurate cut. A feed rate that is too slow can generate excessive heat from friction, leading to blade damage and burn marks on the lumber. The operator must constantly monitor the sound of the saw, the appearance of the sawdust, and the feel of the cut, making micro-adjustments to ensure an optimal balance between production speed and cut quality. This blend of technical knowledge, experience-based intuition, and real-time decision-making is what ultimately separates mediocre lumber production from the creation of truly superior quality wood.